It's not as bad.
You guys ever watch it?
Which is weird because he has a Ford machine in his phone.
Where they're making what it's like. This guy has like a ticket down, like, but they're like doing all the like free boarding things. And like, it's like a really lot of things. Like basically like the last one. Where people like, if you went to this.
Did you write those up there?
No.
I did feel tired. It's feel you could.
And that's
It's 73.
this is actually
How
there.
did you
Like it's
cheating? Me.
points of contact.
Did we come up with one?
Is he the biggest star? Oh, obviously. He's in cute. It's a real question.
We made it after our grandpa.
Trying to watch
I told him
that.
to check it out.
Right? Like, well, anyway.
Yeah, right. Yeah, get it over. I got some things
Huh?
And wait, it's very rare right now.
You too. Oh, Lord, this is a great moment for us to make comments about the out. But also if you watch
What a solution.
our alumni, our whole fund alumni.
Yeah.
Really glad. So I can't.
Service like yours release.
That's not here.
I got so sick of requesting and no one doing it last semester, to be honest. That's fair.
And on top of that, like some of the reasons.
Is there something to drink over there too?
I don't know if it's there or it's in 823.
To like start. Before we used to only the last one, so now it's like.
Did you get your thing ready?
Yeah. Not last year.
And yes, I did make sure.
We had to have it.
I had to download something else. You know how to get it working?
Just a quick announcement, if anybody wants t-shirts at $12 for a short sleeve and $15 for
Or internal.
a baseball shirt. So you can give money to me or Emma
Something like this.
for the t-shirts.
Can I demo you?
Venmo Emma.
Do this.
Oh, yeah.
So what is it? Yeah.
I'm not good at writing things internal.
What did you were using Jupyter?
Yeah, I was using Jupyter.
Oh, so I assume.
I'll send you the link to the-
Yeah.
You have money? Was Pencil using Spider?
I just need PayPal.
I had Spider open on my computer, but I was primarily using that. I was primarily using the Jupyter notebook.
Actually, it's right. That's what I had.
I'll fix it later. I can
I can send you my code for it.
I was just curious if people didn't know how to grab. I know. But if I wasn't able to get it working without downloading some new stuff. Did you do it on your own computer?
Yeah, I did.
I don't know why I asked her. Crazy good.
They just got delivered today.
Yeah. They have a light on the top.
I love those.
Right now, it's
Yeah, super good flashlight. Like, it's strong light. Like, for the fact that it's on a pen, right?
Except for
Very intense.
Ryan Kennedy.
I love it.
Oh, is that right?
How do you distinguish between a necessary and an unnecessary If you're gonna walk, you like it. Come on.
I usually turn that one off. But I got something black, I gotta get the black. Oh, yeah. We'll leave it on there. I'll have to adjust the camera if you're going.
Fantastic.
Yeah, I'm gonna leave that on it. Okay, just for now, that's fine. All right, welcome to our Weather Watch. It's a real thrill to have all the alumni here today, I gotta tell you that. It's fantastic to have so many people who are here today. If you are partaking of the pizza, which I hope all of you are, could you please make sure you've signed in on this sheet? If you already have, you don't have to do it again, but if you haven't, please sign in, because there's some accounting that gets a little bit more smoothly digested if we do that. Pete reminded me correctly to remind you, if you haven't been to this forum before, if you're alumni, and those of you who maybe have been to this thing, this is wide open, okay? So someone has to lead it, but there's no formal hand raising or anything like that. Ask questions when they occur to you. Those questions will either be fielded by me today or probably thrown back to the whole crowd. So that's just the way we do it. It's a very informal but extremely useful weekly event that we have in the department. So really happy that all of you can come here. And I know some of you haven't been here in a while and you're really excited to be back. And so, as I said, I want to encourage everybody to interrupt with questions whenever they want, except Brian Moretsky. He can't ask any questions. And he has to be really formal about the way he addresses the speaker. So he knows that I'm kidding. All right, so we're going to get started. Here's our visible satellite image over the continental United States and adjacent waters from the last 6 or so hours. To my eye, I have to tell you, we're only in the middle of October. And I made this comment in, we're losing our screen.
Oh, it's leaving.
Pete, can't you be in two places at once? Is it really that much to ask?
I should clone myself.
So this is more of a December and January look to a satellite picture than we've seen. This low-level stratocumulus with cold air coming off the continent. I don't remember if it happens frequently in October or not. I think the answer is that it doesn't, but it's a really nice example of an early season cold air outbreak over the northeastern United States and Canada. And here's the culprit, a major cyclone at the southern end of the Labrador Sea. In fact, I just heard from Pete that Michael Morgan, on his way back from Geneva, unfortunately he's not here, he's flying at about 39 or 42,000 feet above this thing right now. And probably marveling at the remarkable size of it compared to his favorite little tropical cyclones that'll occupy maybe 1/10 or so of that area and exert nowhere near as much stirring to the atmosphere. But anyway, that's another story, and unfortunately for many of you, for another day, we won't be here. But we do this regularly, Michael and I argue about it, and then Greg gets involved. It's sort of a tag team. Sometimes he's on my side, sometimes he's on Michael's side.
Maybe if he's watching on the YouTube stream, we can get a live turbulence report from him.
Well, there's turbulence intellectually for sure, no matter what is going on, because he knows he's going to lose this fight. So that's a major cyclone, and we'll look a little bit at this in some diagnostics, which will be fun a little bit later on. And then across the central part of the continent, we have cloud mass of different thicknesses and different vertical depths. The forecast for this morning was exactly on. Wasn't it amazing when you think about it, that there was a forecast for rain between 9 and 11 o'clock, and we had a period of pretty heavy rain, and it's probably going to clear out later in the day. So that was right on. Looking at yesterday's and the day before's forecast models, really had a light but short duration event over us in the mid-morning, and it was right on target. It's been raining all week long in Texas. In fact, all month long. They've had, I wrote down some statistics for Dallas as one example. Dallas has had 10.62 inches of rain in the month of October. And they consider their fall season September, October, November. They had 23.3 at Dallas since September 1, which is already a record for the season. But it's not yet a record for October. They're about 3.5 inches shy, and it's only the 19th of October. So, and there's more to come today. So they're likely to have their wettest October and already have their wettest autumn of all time in north central Texas. And today is just one of several days that have, been associated with that. I think I have some elements of an explanation for at least the second half of this month of October and why it may have been raining so heavily there. That is related to some processes that have made us stay a little bit cooler than normal. We've been about a degree colder than normal on average through the 18th of October. And that might not surprise anybody. What did surprise me was to recollect that we had a temperature well above 80 in the first couple of days of October. I didn't remember that. I remember the month being pretty much cold the whole month, but so that's a bit of a surprise. It was front loaded with some warm days, which has only given us slightly less than a degree of negative departure. But it's been an extremely rainy October as well. And I think even if you've just paid attention anecdotally like I have to the month of October, we, as years go by anyway, we usually have a dry first 2 weeks of October, as by my recollection. Not true this year. And we're 3.5 or 2.5 inches above normal. And the normal to this point is about 1.5. So we're way above normal for the month of October in precipitation. Okay. And then we can't see it quite off of this map, but we'll go to a satellite movie off the West Coast if we could, Pete. Take a look. Maybe we'll have to use the infrared because it's this time of day.
Michael did try to connect. He said the connection on the airplane is pretty bad, but he said you should check your phone.
Do it publicly. Hi, John. That's all he has to say.
John, well, you're going over there for all us East Coasters who don't really care about the Midwest anymore.
Yeah.
That's why you're not allowed to comment.
Yeah.
I told you. You got to watch out for people like it. But I knew that ahead of time.
Has it been the pattern related to the enhanced tropical but colder pattern over Madison? Has that been sort of a combination of maybe enhanced activity in the East Pac and the MJO over there, the tropical, and then some pattern leading to the colder weather over here, so that's why you don't necessarily see that at the beginning of October, but it's just been that pattern?
I guess I don't know enough. Greg's shaking his head yes. I noticed for the whole, since September 1, I stopped keeping my 850 millibar -5 isotherm movie from the 1st of September on. And I've noticed that for much of the first 6 weeks of this season, there's been almost no cold air in the Eastern Hemisphere. And so Siberia, Mongolia, until recently, within the last week or so, there was almost no incursion of the -5 air to those latitudes and those locations. And that meant that they were running 2 and 3 standard deviations above normal in the lower troposphere for an extended period of time. Now, Judah Cohen has kind of picked up on this. Judah Cohen works at this company out in Lexington. And he's really interested in foreseeing what the winter might be like over North America and parts of the hemisphere. And his conclusion to this point, anyway, I just read about it, but not in any detail. He says lack of snow cover in Siberia, Mongolia, is kind of pointing towards a little bit milder winter, at least the early part of the winter, by his estimation. I guess he's got a series of different predictors that he thinks about to get that forecast made. And that would be in line with it being unusually warm there. I was also worried about the ice over the North Slope of Alaska because they were one of those other places that was part of that really unusual warmth on the far western, eastern edge of the Eastern Hemisphere. And so I don't know what the status of the sea ice is at this early part of the season. It should be refreezing, but after having been eroded away in the summertime, but I bet that refreezing is behind schedule. And so that's probably a factor in at least a chance for a little bit more ocean effect snow in northern Alaska. So it's hard to know exactly what might transpire. In terms of connections between MJO and ENSO and things like that with respect to cold air in the hemisphere, I don't really know enough to say. Greg, why don't you say something?
I would say that the East Pac has been very active this fall. It normally is active in the fall, but this fall, more active, and several of the storms have curved into the Baja. In almost every case of these heavy rains in Texas, the flare-up of Michael, all these things are connected to those East Pac storms. And so the very active tropics, and remember that they observed sea surface temperatures off of San Diego at 80 degrees this year, some of the warmest ever observed there.
What's the average? Do you know offhand?
They usually wear wetsuits, so it's not 80 degrees.
Oh, okay, yeah, so it's gonna be below 70.
Yeah.
So
So
that's
it's,
way
so it's very unusually warm there. It's not an El Nino. It's not warm out at the equator yet. There's some signs that it might happen, but there's no El Nino now. But the coastal waters around there are very warm. And several of these storms have kicked up to Cat 4, Cat 5. I think there was a Cat 5 storm headed out to Hawaii.
Yeah.
Right, so there's been some very large storms, and their outflows have been enhancing the subtropical jet. And the subtropical jet has been pumping the Gulf moisture into the Midwest.
Yeah.
So they're connected.
Yeah, so there's some interesting connections that are worthy of further exploration for sure this year. And what I brought your attention to this satellite movie for was because we've got this first of its kind this year, it seems like, again, fairly late bloomer, first of its kind intense cyclone in the Gulf of Alaska. And we followed this a little bit this week in 452, and you can see this is infrared, but you can see the enhanced convective clouds, not only enhanced low cloud top temperatures, but also probably enhanced spacing between cells, indicative of really cold air aloft. So this is a really intense upper wave, and it has spawned a monster of a cyclone, which I think, what did we say yesterday, Leo? We had a sea level pressure drop of something like 26 millibars in 12 hours at one point in the evolution of this thing. And I've lost some of those maps. We're going to look at a collection of things to diagnose aspects of this storm in a minute. But I lost some of the ones that I'd hoped I'd be able to show. But I could recover them, but I can't do it in real time. But I'll show you some interesting aspects of this development that is among the first explosive cyclones in the season for the East Pac in the northern the high latitude. So it's a really beautiful storm, and you can see where gorgeous cloud head in the eastern and northern part of the storm, and then a trailing cold frontal structure, and then a nicely wrapped up occluded structure probably as well. And there is the peak of the coldest air at 500 millibars, almost surely just about coincident with the minimum in geopotential height. And then down shear of it, because the thermal wind is in the direction of the cold front, down shear of it is where you're forcing the air to get out of the center of the column in the cyclone. So it's a really beautiful example. I'll show you some diagnosis of that. And then we've got a series of waves that we'll be able to see better when we look at 500 millibars in a minute, coming down in northwesterly flow across western and central Canada. And here's one with enhanced cloudiness now over the central part of the state of Minnesota. And that'll be making its way through. So we started out relatively mild today. We're going to see this upper wave go by, and it'll begin a period of, we're actually exceptional cold for tomorrow. We're going to be really much colder than normal tomorrow, and then a little bit of warmth coming in. In fact, one of the waves in this train, I will predict right now, will give us our first visible snow flurries midday tomorrow. I think we're going to see snow in the tomorrow. As the corporate Los Angeles Dodgers make their way back to Miller Park and are nervous to see snow. Some of them, many of them, have never seen it before, and they will never see it again.
I think they're just going to put the top over.
Well, they will, but they still have to get into the park, and they're not going to like that. Poor little Cody might not like being so cold, so we'll see about that. Okay, let's take a look at the super peats. For those of you who don't know what I'm talking about, we look at these giant hemispheric, almost hemispheric scale maps, and look at, they're even labeled on Pete's pages, just super peat. They're these beautiful, large, various isobaric analyses. Oh, yeah, sorry, Pete, I was pointing at, I thought I was at 500. Let's go to 500 first. So you can see they occupy a pretty large area, continental United States, Canada, and adjacent waters. So this is the 500 millibar analysis from this morning. The red lines are isotherms every 5 degrees, and the black lines are geopotential height, and then the observed winds and quote-unquote observed geopotential heights missing the leading 5 are indicated in green, and then the dew point, not dew point depression, but the dew point, no, dew point depression, sorry, on these maps, it's dew point depression, is underneath the temperature. So we see a couple of, well, first, a broad, intense flow, just kind of kissing the northern boundary of our country with Canada, and then wavy over the Pacific. This is an intense wave. Remember, our cyclone's crashing in to coastal Alaska, and it's associated with this upper level disturbance. And then we have that massive storm just at the mouth of the Labrador Sea that Michael's flying over right now, south of Greenland. That's tied to this broad upper wave. And extraordinary variconicity. This is a 15-degree horizontal temperature contrast with a sort of 6,000 kilometer long synoptic length. So that's a really intense upper front. Probably we'll see better ones as the year goes on. Here's a northwesterly flow within which little waves are embedded. There's one just south of Lake Winnipeg. There's one over Minnesota right now. That's the one from 7 a.m. this morning that passed across and gave us our precipitation. So there's a series of little waves in this northwesterly flow, and it's a fairly cold northwesterly flow, minus 30 up near Great Slave Lake, minus 30 in Lake Winnipeg at 500. And so these waves are likely to develop in this region of baroclinicity. And the second one, I think it's this one here, I think we're going to watch out for tomorrow morning for a threat of snow. We'll see that in the forecast. And then pretty intense baroclinicity, in this case, on the eastern side of an upper trough axis. That's just the vertical extension of a deep cold front. That's really a nice structure that's going on in association with this storm. And then out ahead in the southerly flow, warm air pumped up over the coast of British Columbia, and that just enhances the ridging that's been going on most of the month in similar types of, but not as high profile, high intensity events in that same location. Anytime there's a ridge at such a longitude as what is 120 degrees west, there's almost always in the cool season a downstream trough, and that at this time of year drags air right off the archipelago down to the central U.S. without interruption. So we stayed cold, but only a degree colder than normal, but nonetheless persistently so. Okay, so let's take a look at some other levels. How about the jet level at 300 millibars? So the jet is very wavy over the continental United States and adjacent waters, very high amplitude flow south of the Aleutian chain across the western United States and Canada, and then a little bit of a more of a flat flow across the central and eastern Canada, and then again another intense trough. So this is an unusually wavy flow that's going on right now. I think what's going to be interesting, I remember right, we're looking at this no, it wasn't a forecast, it was a series of observations. We've had a series of pulses coming out of the northwesterly polar flow that have been riding into this persistent southwesterly subtropical flow. And every once in a while, there's a flare-up of the subtropical jet wind speeds. And that's a really interesting phenomenon that has probably, and here's the entrance region of such a jet, although it's not really an intense entrance region acceleration, but that's been a factor in promoting the persistent rains across central and north central Texas. Right.
There's also that Rex block on the west coast. And the question with that Rex block, there's a Catalina low there.
Yeah, so here's the block you mean, and then there's the low off Southern California.
Yeah, it's a Rex block because you got the high over the low.
Yeah.
But the Catalina low is interesting in that I think if you look at the low levels, it's getting some flow off the mountains, and that tends to hold that stationary there with the marine boundary layer. Conservation of potential vorticity in the marine boundary layer across the coastal range of mountains. And so there's a topographical influence there. That used to be, I was talking to 100, I say it used to be one of the most impossible things to predict. When
I remember that, yeah.
But I don't think it is anymore. I think the models can get it.
Yeah.
But I wonder about that ridge to the north. I think that's why the cold air has been dropping over us the last couple of weeks, is because of that persistent ridge there.
Yeah. I think you're right about that.
Blocking the waves from coming straight across. So.
And part of it has been fed, although not as dramatically as now. This is obvious with our big cyclone there. That's certainly a ridge builder, but it's not been so obvious over the last 2 weeks what's kept it there. So Melissa should comment. Perhaps you've been thinking about this.
Yeah, I haven't been paying attention except knowing it's there.
Yeah. I wonder if there's something systematic that's been going on. So that's a really interesting collection of ingredients that gives us a good indication of what the weather's going to be. I also been telling people in 452 in our discussion, when you get a jet in northwesterly flow like this, with the exit region, in this case, just about over Lake Winnipeg, this is the region where it's not very strongly curved flow, so it's going to be mostly the long flow speed change tendency to produce ageostrophic divergence in this location, and so column ascent. And that's going to be in a spot where if you make the air rise and it gets colder, the thicknesses drop. And so you tend to intensify this trough, and that's the thing we got to watch out for on Saturday. It's going to be a pretty potent little disturbance, and at least so long as it stays in northwesterly flow, it's very hard to erode those troughs. They, in fact, tend to get a little bit more intense. We'll see that reflected in the 500 millibar vorticity when we go to that. So two things we'll do today is we'll do a little bit of prior diagnosis, or diagnosis of at a prior time on this storm, and then more or less real-time diagnosis on that. And then we'll be looking into the future for what happens over the western Great Lakes states and central plains of the United States into the weekend and early next week. So that's the broad setup. Can we take a look at 850 millibars? Pete?
Look at 200 millibars first. I mean,
Oh, all right.
you're missing the real jet.
No, I'm not. It's right there. We're already above the jet.
Look at this.
Oh, you
one.
mean this one?
Yeah,
okay.
yeah.
You mean this one?
That's
Oh, yeah.
that's being driven by Sergio.
Well, when is Sergio going to die, Greg?
Sergio's gone now.
Okay, he's gone.
But there's two more that are forming, and all their
Okay.
alphabas going up there
Okay.
and driving those things.
Okay. So yeah, this is subtropical jet. The higher one goes, the more obvious it becomes at various levels. We may be above the core at 200 millibars. Let's do 250 just to make sure we're not.
I think you might be right.
No, it is higher than that. It's
Go to
200. There's a
150.
really high tropopause from the tropics. Yeah, let's see what it looks like at 150. Yeah,
Oh, it's gone.
it's right at 200. Okay, so 200 millibars is the tropical tropopause height, and it's over Texas, and it's over Kansas. So, we're not out of the summer yet. If you live this far south, Zach, you can testify. Maybe Chris, you can too, right? This is still summertime, but and there's some evidence for that given by the subtropical jet. And this thing is the core. This is lower in elevation, but here it comes. There's going to be some sort of phasing later in the weekend, as there was earlier this week with another wave that came
So
south.
that's what's off the east coast.
Yeah, that's right, and that was a major development.
That's a combined subtropical polar jet.
That's correct. Okay, so thanks for dragging us up there, Greg. That's about what Mike was at flight level. So here's 850, and here's kind of an unusual structure. Not unusual, but intriguing, I should say. This is from this morning at 7 a.m. So here is the plus 15 degree isotherm, and you can see that there's a warm axis right in the middle of this, from central Minnesota down to the observation at North Platte is 16 degrees at 850. So it's very warm. This is lee side because there's high terrain like this. It's not really the strongest lee side feature that you've ever seen. In fact, there's high terrain in the Black Hills, but it's like a lee side trough in that the trough axis is coincident with the warmest air. And that's not going to last very long because it isn't strongly forced by westerly flow over the high terrain. Behind that trough axis, there's a region of sort of uniform cold advection, and that will gradually become non-uniform as all the isotherms get piled up near the trough axis. And we're seeing a little bit of that cloud feature along the leading portion of this developing, what I'll call a developing cold front across Minnesota in the satellite. So that's the breeding ground for what's going to happen with our next wave. So simultaneous with development aloft, there'll be importation of colder air. We're pretty warm now, 8 degrees at Green Bay, same at Davenport, a little warmer down near Lincoln, Illinois, and 8 at Minneapolis. So it's uniformly about 48, 46 degrees at 850. It's going to get colder. And as it gets colder, there's a little more cyclonic development that will be fostered by independent but related processes. And here's the intense minimum in our geopotential height at 850. It's down at 1,140 meters above sea level, just south of the Panhandle of Alaska. That's an intense cycle. I didn't have to tell you that. We'll take a look at that. Let's take a look at the national radar now, Pete, if we could. First, yeah, we'll do that first, and then we'll look at the surface off, and then we'll move on from there. Okay, so here's the national radar mosaic across the entire continental U.S., some of the adjacent waters. Nothing seems to be happening in the adjacent waters, but here's the precipitation that came through us earlier this morning. I guess that is a good way to track where that upper trough axis was, because I think it's just east of that where the precipitation has been formed and is maintained. So now that's just about through us or close to it. And then down here is maybe an extension of that precipitation band, but forced by a slightly different mechanism. I think this is
Called subtropical jet.
well and weak horizontal frontogenesis in the middle and upper troposphere. I didn't bring that in, but I looked at it myself, between 700 and 500 millibars. And so that's consistent with stuff going on in the middle and upper troposphere. And certainly the moisture source is ushered in on the anticyclonic shear side of the subtropical jet. It's a big anticyclone sitting in the eastern part of the Gulf of Mexico. So that's maybe it has elevated origins, this precipitation band. I'd like to see what the clouds actually
Well, the
look like.
precipitation band, the dynamics, is
Yeah.
coming from the subtropical jet and pulling Gulf moisture. So it's the Gulf moisture being driven by the circulation around the subtropical jet.
But it can't just be the jet, because if it were just the jet, you wouldn't have a linear strip of ascent. Right?
No, you would.
No, why would you? Why would the jet
No, we
give you?
don't-
Why would the jet give you a linear band of ascent that's parallel to the jet?
Because there's an upper level discontinuity there.
Of what kind?
Well, there's a convergence field there associated with the circulation around the jet that's pulling the moisture into that convergence field a lot. And the moisture streaming. See, the moisture isn't crossing it yet. The moisture is being brought up and then brought along with the southwesterly flow.
Yeah, my idea is, got elements of what you're saying. My idea is that if you have a jet up here, you have to have some barochronicity hanging down below it, even when it's a subtropical jet.
Well, the subtropical jet creates it.
Well, if it's there and it's acted on by horizontal.
It's a weak
differential
barochronicity, but the circulation around subtropical jet does a frontogenesis job on the lower
Yeah,
level.
and that's what I'm attributing the banded nature of that to.
So we're both talking about the same thing, but the root cause, in my opinion, is the outflow from these tropical factors.
So you're trying to get to the Aristotelian core of why it's raining in Texas. And I'm just satisfied to say, I've got a structure I can identify, it's frontogenetically active.
Yeah,
That's
well,
good enough for
I
me.
try to do it like that because there's something unusual about so much of this rain.
Yeah, I think
This season.
I think that's
And
right.
I think what's unusual is the existence of all these storms that keep giving a subtropical jet over that area,
Okay,
driving it over that area.
that's a fair way to phrase that. I think I agree with you, that there has to be something else to explain the frequency, not just the instantaneous situation today. Yeah. But that is, across the central US is really all that's going on precipitation-wise across the country. So before we do some diagnosis, let's take a look at the surface odds across the country on that big map, Pete. We don't have a name for this one.
It's called the US surface map.
Yeah, it's very boring. It's very British. That's all it is. So here's Madison. We're 50 over 44. We have had dew points in the low 30s, actually below 30, not that long ago, less than 2 days ago. I think I had a low temperature yesterday morning at 30 degrees. Today's minimum temperature was actually the midnight temperature, and it's going to be warmer most of the rest of the day. But southwesterly flow prevails across our region and to our southwest. But when you head to the north and west, you can see all of these northwesterlies, and so the boundary is somewhere across Minnesota and maybe the northern and western edge of our own state. But since the sun is out, it's one of those interesting days where the insolation, even with lower dew points and colder original probably potential temperatures, the insolation is sufficient to get you temperatures higher in the sun than in the clouds, because this isn't super cold air to begin with. That air is still far to the north, but it's on its way. And then scattered showers still exist across the state of Illinois. Not very many across Wisconsin. It's still raining at Green Bay. And then it's maybe lost across Lake Michigan. And in Michigan, perhaps they don't care or it's not raining. And then further to the south, from St. Louis, actually from maybe Springfield southward into central Texas, it's raining across most of the region. It's not surprising after what we just saw in the satellite. And there's Dallas, still suffering from moderate rain. Then they've had a really wet, north central Texas has been really wet.
Can Pete put up that first frame of the jets that I have, the subtropical, I just want to show you the context of this, in the big picture. I think it makes a lot of sense when you look at these jets.
Okay.
Just the first frame of the 6Z global jet.
This one?
Yeah. Let's get the first frame up there. Okay, you see that arched plume over the southeastern United States?
Right here.
Yeah, that's being driven by that's a tropical plume coming up, and the colors on there are potential vorticity, which shows very, very low. The bright colors are tropical potential. I use Miami colors to make it look like it's to notice the tropics. So what you see is a plume with an axis where that's arched, that subtropical jet that's arched over there, has an axis over the southeast. And then it's got a circulation along it that's bringing up that Gulf moisture.
How is the, what? Explain to me what you mean when you say it's got a circulation along it. What do you mean?
It has, well, there's acceleration into the jet
At the entrance region,
at the entrance region,
Yeah.
and then there's deceleration out
at
of
the
it
exit.
at the exit region, right? So in the entrance region, in the south, like over Mexico, the air is generally
Yeah.
kind of rising and converging. So that's bringing in,
Yeah.
what that's doing is
That's
it's
going up.
drawing air in from the southeast into that jet. That's what you see in the Gulf. You see that southeast flow being driven toward the jet at low levels. These plumes like this, always on the western side of these tropical plumes, you always see some kind of a atmospheric river of moisture coming from the tropics. And there's kind of a river of moisture right now flowing out of the Gulf into the entrance region side of this jet stream.
Which Gulf? Gulf of California or Gulf
No,
of
Gulf
Mexico?
of Mexico.
So how is that not tied to the anticyclone that's sitting over Florida?
The anticyclone is the tropical plume. The anticyclone is there because of the cold air very high that's producing higher pressure at the ground because the mass of the air is so high with that tropical tropopause. And that's causing the high pressure at the ground. And the circulation around the high pressure is what forms that convergence along that region there that brings in a plume of tropical moisture, a narrow plume, a kind of a river of tropical moisture into that circulation. But as long as you keep reinforcing that circulation aloft with these tropical systems, that'll keep happening. But you can see the polar jet on there. You see the polar jet ridging over, it's getting caught up in a little bit.
Yeah, here's one,
It's not,
and here's the one.
yeah, it's
That's
not
over
colored
Canada.
like the other ones because it's got high potential vorticity.
Yeah.
But, and then they kind of merge together off in the Atlantic. But you could see all these subtropical jets that are moving along there. But this one's been fairly persistent with that ridge on the south. And the ridge will shift back a little bit and oscillate a little bit east and west, but it's mostly been there. And that's that high, we've been talking about it all fall, about that very high tropopause over the southeast.
Okay. Okay, where were we gonna go next?
You were on the surface map.
Yeah, I think we're done with the surface map. Because all I wanted to show is what sort of air was down there. And we've done that. So now, let's take a look at some diagnostics from the storm off of the Maritime, over the Maritimes. And I want to, before I show you what I have, I want to, well, first, we can show a couple of them. If we go to that, it's not up here, Pete, it's, where is it? It's the terminal. Okay. No, it's not. Get this out of the way so I can see where we are, because I have. Yeah, this set of GIF images. So let's take a look at this, put this on the corner. Yeah. So, and don't click through yet, if you would. This is the 16th of October, so a couple of days ago at 18Z. And this at the time is the minimum geopotential height of 1,000 millibars associated with this storm that's now at the mouth of the Labrador Sea. At the time, it was just south of Newfoundland, or just in the northwest of Newfoundland. And it had a really deep minimum, so that's 32, 64, 3, 4, 5, 6, 7. So it's something like 972 at the time, central pressure. So it's a very intense cyclone. If you go to the next image, you can see the frontal structure. Here's theta E at 1,000 millibars, so a really intense cold front, sort of a widespread region of almost uniform warm advection that might be on the warm edge of the warm front. But anyway, the cold front's really intense. And so what I wanted to do was show you some things that Kate Abbott and I have been working on. And Kate is interested in, we're trying to figure out a fundamental partition for the vertical motion field. Instead of going to the quasi-geostrophic system or something else, is there any other way we can look at the total vertical motion field and understand some of the underlying causes that are forcing it? So that's why I wrote this stuff on the board. There's two expressions. One of them is the vertical cross product of the acceleration vector gives you the ageostrophic wind if you start with the frictionless equations of motion. And then the other on top of it is even more fundamental. It's just the isobaric continuity equation. But what's really kind of cool is if you take a wind vector V, either of those two pictures, the right one or the left one, and you somehow impose an acceleration on the first one, let's say, what you're going to do with that acceleration is change the direction of the original wind vector. And that will be associated with, that process is associated with an ageostrophic wind that is along the original wind vector. In that case, it's pointing against it, but if you were turning it the other way, it would go in the same direction. So there's a component of the ageostrophic wind that's along the wind vector that will be related to direction changes. And then on the other picture, with the same V to begin with, if you want to change the speed of it, you've got to have an acceleration that moves in the direction of the wind vector, but that will impose an ageostrophic wind that's perpendicular to the wind field. And so that speed change part of the ageostrophy will always be perpendicular to the wind field. So here's the idea that I have. So let's try what this one says next, Pete. Let's go to the next one. I don't even know what that is. I don't know why I did that. Let's go to the next one. No, that's not. Keep going. They might have just put them all together. This is the wrong time, so let's keep going. And keep on going. I don't know what this is all about. Might be from prime time, but don't worry, we're gonna get to there eventually. Here it is, okay. And go ahead one more, if you could, Chelsea. I've got them labeled so I know. Okay, so this is the 500 millibar vertical motion at 18Z on the 16th of October. So that's when our cyclone was sitting right there. So the blue is ascent and the red is descent. And so very intense updraft. It's embryo. It looks like a little embryo of updraft along the cold front and right near the center of the storm, and then some weak regions of downdraft. And this stuff is unrelated to our storm of interest. Now, if you go back one, Jetpack's a really powerful program. So you can take all of the ageostrophic winds from 1,000 to 100 millibars, integrate them using the O'Brien method, and this is the vertical motion field you get when you do that. So this is just the integration of all of the ageostrophic winds and their divergence. And if we can click back and forth between the prior one and that one, there's very little difference. Okay, there might be some numerical difference, but even that is small. Certainly the geometry and distribution is just about exactly the same. So if we go to right here, now what I'm saying is we can partition that into the integrated divergence of just the ageostrophic wind that's related to direction change, or the integrated divergence that's related to the speed change. That's really interesting. Let's see what the next one is. I forget which one it is. Go ahead one more time. This is the speed change part of the ageostrophic wind integrated to give me 500 millibar divergence. So some of the frontal ascent is related to speed changes. A giant part of this, this is a huge ascent maximum sitting over to the northwest of Newfoundland that's tied to speed changes. And really weird things go on over Greenland. And then let's go ahead one more. This is the direction change, and they are completely opposite each other in certain locations. They add together near the cyclone center, but they're opposite in other locations. We're still trying to figure that out. Why is this, and is it systematically the case that you get a lot of cancellation, and why would you get cancellation? So we're trying to figure it out. But if we go back to the prior one, that's the speed change part of the ageostrophic wind integrated to give me the vertical motion. And then the next one is the direction change. No, gotta go forward. And then that's the direction change. So we're trying to figure out what's going on with this in a systematic way. So it's really an intriguing way to think about, I think, an intriguing way to think about the vertical motion field without reference to any other sort of assumptions. So that's where we are on that. And anyway, either way you look at it, the vertical motion is intense right near the cyclone center. So it looks like it works pretty well, but I don't know what else to say about it. Okay, so that's a little bit of thinking about what's going on that storm. Let's go back to the Pacific storm, if we could, Pete. And I lost some things that I wanted to show you, so let's go here first. This is Alicia Bentley's collection of maps that she makes from the GFS model. And I'm showing you, I need to see the time, sorry. There it is. Okay, this is 24 hours ago, where our Pacific storm was fairly weak. So this is just 1,004 millibars, 1,008 actually, 1,004. And what you're seeing here is isobars are in black every 4 millibars. Then thickness from 1,000 to 500 is red if it's above 5,400, and then blue if it's below it. That's a 60-meter interval, and then 250 millibar isotax. So I'm not so interested per se in the jet, but I'm more interested in the sea level pressure. So let's click ahead here, Pete, a couple times. And then here we are just at 0Z last night. Cyclones deepened substantially. This is 406,992, so it's gone down something like 12 millibars in 12 hours. And it's, as you can see, strong thermal wind indicated by the thickness gradient rushing straight towards the center of the storm and then coming out the top. And let's keep on going. So here's 12 hours later, we're well down into the 970s. So that's the period of explosive development, during which time the thermal wind was still straight along the cold frontal portion of the storm and heading right into the cyclone center. Okay. And maybe that's good enough. So now let's go to these maps. This is my vertical motion stuff that I'm looking at, positostrophic vertical motion. Slide this thing up so I can see the time. Yeah, no. I got to use this one, unfortunately. So this was initialized yesterday at 0Z. And so I want to look at first the 0-hour forecast of the total omega field. Now you can't really see the thickness
You
line.
might want to turn that light up.
Oh yeah, I know.
You'll get better contrast.
Let's turn this off too. Yes, I can. Okay, yeah, you can see this a little better. The dotted lines are 500 to 900 millibar thickness, and then blue is descent QG descent, and yellow is ascent. And the cyclone center request was right about here. And so it's strong ascent right on top of the cyclone center, not surprising. And if we split this up into, well, first let's look at what the most fundamental way of looking at the QG omega is, which is PVA NVA by the thermal wind. Let's take a look at that, which is the Sutcliffe-Trenberg omega. And you get a cartoonish version of the same answer. Strong ascent over the cyclone center, strong descent. Geometry is roughly the same, but as I say, a little fuzzier, a little more cartoony, because it's not the full QG omega. But you get a nice picture of a couplet of strong descent, strong ascent sitting right on top of the cyclone. Now, what's interesting is you can take a look at, since this is PVA and NVA by the thermal wind, you can split the vorticity into shear and curvature and see how they look, how they behave in the same situation at the same time. So let's go back to that and we'll look at the shear vorticity advection by the thermal wind. And you get a decent amount of ascent over the cyclone and some descent back on its up shear side. So let's count 4 different contour intervals with a concentration right in the middle there. Let's go to the curvature vorticity advection at the same time. And I get roughly the same intensity, but a different distribution. So at this time, they seem to be roughly doing the same thing. Let's do the same analysis at 12 hours in when the storm's more intense. So we'll start with the Trenberg, Sutcliffe, omega. So it's pretty intense updraft right to the northeast of Kodiak Island and strong downdraft. Here's the development. So let's do the shear vorticity advection at that time. There's only 5 contours there, and then let's do the curvature vorticity advection. It's about the same, although the intensities may be a little bit greater at the center of this thing. So what's happening in this storm, it seems to me, is that there's almost an equal partition between how the shear and the curvature vorticity are influencing the development. That's not true in all storms. Sometimes there are storms that have a much stronger contribution from the shear or a much stronger contribution from the curvature. And so we're exploring that too, trying to figure out if there's anything systematic about the environments which tend to produce one bias versus the other. So that's kind of an interesting thing. So you can have some fun picking these forcings apart and trying to understand how the atmosphere is producing storms, especially when they start to get energetic like they are now. So I think that's enough for this. If there's no comments or questions, maybe not. I'm looking at the board more than you, so you gotta just say something. Okay, let's go away from this, Pete, and just one other thing I want to show you is that, yeah. So I'm looking at every day the 850 millibar -5 isotherm over the northern hemisphere. I calculate how much area it encompasses, and then I do it 4 times a day with the GFS data, and then I compare it to the daily average in blue, calculated from almost 70 years now of the NCEP reanalysis data. People who complain, oh, don't use the NCEP reanalysis data, it's not very good. It's a temperature measurement, for God's sake. I mean, it's pretty fundamental. You're not going to go that far off in the lower troposphere, though their arguments are well taken. So here by the middle of October, here's the time series for this year compared to the average. So over the whole hemisphere, we've been a lot warmer than normal, and there's been a consistent warmer than normal for all of these different days. And yet we've been a little colder than normal, I think mostly over North America, certainly here. So that's always intriguing to me. How does, and under what circumstances does the hemisphere present itself as warmer than average, and do locales present themselves as colder than average? And are there systematic circulation anomalies that make that the case? Because I was thinking about this again the other day, to the extent that every single year on October 19th, the sun is at the same angle at every single point in the northern hemisphere at the exact same times of day as it was 150 or 300,000 years ago, pretty much, 300 years ago anyway. Isn't it true that differences in how much cold air there is partly, or maybe even strongly, a function of circulation anomalies? It has to be, because the radiative conditions are about the same every single year, with the exception of snow at the ground. But if you're at 850, that doesn't have the same impact as it would at 920. So something's connecting temperature anomalies hemispherically and circulation anomalies, and then regional versus hemispheric, something there. So it's interesting. Anyway, wanted to show you that. So now let's take a look quickly at the forecast. And we'll do that with just the GFS. And let's start at 500 millibars at 12 hours in, Pete. So this will be valid tonight, 7 p.m. Oh, no, let's do 0. So we can, yeah, I think you had that instinct. I should have just let you do it. So here's the initial time. We looked prior to this at the observations, of course, at 500 millibars over a slightly more limited region. So here are the features of interest. Here's the big vorticity feature aloft associated with the storm in the Gulf of Alaska. Surprisingly, I think surprisingly to me, it's kind of a strip with a bulbous head, and so it's down sheer of the bulbous head where the development's really most intense. But this line of intense vorticity is reflected by that frontal structure we saw in the 500 millibar isotopes. So that's a really robust front through a deep layer. And then this interesting couplet of positive and negative vorticity straddling it indicates there's a strong wind speed maxima there, and the geopotential height suggests the same thing. And very often, the presence of the negative vorticity is enhanced by convective activity. And so that's potentially convectively unstable air that's been put up in updrafts and producing a rain band. And so it's not uncommon to find pretty intense precipitation in the forecast panel at the same time. We won't find that now because this is an analysis. So that's one feature of interest to keep an eye on. We had rain across the central plains this morning, some of it through Kansas and Missouri into northern and central Texas. That's probably related to the passage of this draped around upper trough. Certainly that was true over us. And then this feature over Colorado had some impact on the precipitation that was observed just to its south and east earlier in the day. And then here's the upper wave just near Churchill, Manitoba almost, just to the north of there. That's pretty intense and isotropic, nice and circular. Watch out for that one for Saturday for us. So let's now go 12 hours ahead and see what happens with some of these features at the same level. So we started out just north of Churchill Bay, and now we're sort of in central Manitoba. And with that feature, and so it's getting closer and closer to Madison. This is a really intense upper trough. If this were January, we'd be looking at a really serious cold outbreak. It's already going to be cold, but it won't be so cold that you freeze. And then the upper wave associated with our cyclone crashing into the southern Alaskan coast has gotten itself a little bit disorganized. The cyclone fills by something like 20 millibars in 24 hours. So it disappears rapidly when it makes landfall up there after it was down into the mid-960s. And then our storm off the Atlantic coast, the nature of this upper trough has changed over time. I won't emphasize it, but there's less curvature and a lot more just speed shear and not so much curvature variation there. So this feature here in central Manitoba is imposing itself as time goes on towards us. I'm going to leave the pointer right in the middle of that vorticity feature, and let's go to the 1,000 to 500 millibar thickness surface forecast. And you can see that's the location of the upper vortex. There's a broad thermal wind that's fairly intense to its south and west, and we're going to see at some point this wave gets itself in front of that thermal wind, and it starts to be regions of PVA by the thermal wind down sheer of it that will spawn a very weak amount of precipitation in the forecast. It'll kind of drift right over us into Saturday morning. Okay, and there's the cyclone, or the cyclone with which our precipitation this morning is associated as well to our north and east, and by this time even further so. But you can see there's widespread but usually light precipitation associated with it. Okay, and let's go to 850 at this time, Pete. So this is tonight, about the time the game begins. There's something funny about the winds here, but you can see the geopotential heights are in white. And so here's the pool of cold air associated with that upper wave, that local vorticity maxima. So there's really strong cold advection at the front edge of this thing creeping into northern Minnesota, and without any obvious reason why it won't subsequently creep into central and southern Wisconsin. And you'll see that turns out to be true. So let's go to 24 hours in the forecast at 500 millibars, by which time, look where the wave is. It's still nicely isotropic, and it's south of the Arrowhead region in Minnesota. So bearing down on us, sort of toward La Crosse, very intense wind speed maxima implied by the geopotential height gradient across central Minnesota and then headed into southern Wisconsin. So this is a fairly potent wintertime type feature. And let's go to the sea level pressure analysis and forecast. Knowing the vorticity maxima is right there near Superior, and you can see there's the thermal wind cutting right across it, immediately down sheer of it. So there's where the vorticity max is, immediately down sheer of it, this little patch of forecasted precipitation. And thickness, the solid white yellow line there is the 540 decameter thickness line. We're well below that. We'll look at 850 temperatures in just a minute. So this is light precipitation, almost surely hitting the ground as snow just to the north of Dane County at 12Z. So let's see what the 850 millibar temperatures are at this time. And we are right on the border in Dane County of about -2 to -4, and it's much, much colder. It's in the -10 to -13 range over La Crosse. So here comes the strong cold advection. And right at the leading edge of it is where that precipitation forecast is. So let's now go to a 30-hour forecast, Pete. This will be valid at around noontime tomorrow, by which time, actually, let's go to 27 so that we're a little bit upstream of this thing. So, what? Something's funny there, isn't it? Okay, I don't know what's funny about this. This just strikes me as we haven't contoured it the same way on all of the maps. Okay.
Yeah, it's very.
All right, let's go to the 30, I guess. Because we'll still see the same relationship. Here's the maximum sitting right over Dane County at 500 millibars by noontime-ish tomorrow. And so let's do what we just did. We'll go to the 1,500 forecast. And one can see a strong thermal wind again, and down shear of it. PVA gives you this patch of precipitation, which, remember, was over in the northwest part of our state 6 hours before this, and is now here 6 hours later. So my forecast is we're in the middle of snow flurries, right in the middle here, 9 to 10 a.m. tomorrow morning. And I'm not going to bet anything on that. It's too much riding this week on all sorts of things. I'm not betting on anything, but it's a pretty darn good bet. I think we're going to see some snow tomorrow morning when everyone's awake and able to look out the window. We had a little bit in the air at 11:30 or so the other night, which is fine. I mean, it goes on the record, but it's not the same as seeing it. So tomorrow morning we'll see it, which will be really nice. But if you don't like snow, I do. I get excited about this. It's going to be darn cold. These thicknesses are really low for mid-October. And there's a big anticyclone to our west, pumping that cold air. And it's really, the depth of the cold air is going to be right over us midday.
What's the temperature at the game tomorrow?
Sorry?
At the game tomorrow, what's the temperature?
Oh, what time is the game?
11 o'clock,
Oh, 11 o'clock?
right about this
I
time.
think the temperature is like, it's going to stop snowing, so the sublimation will be over. It'll be 39, 40 degrees.
Well, then more.
Yeah, maybe it won't even be that.
I was thinking the 850 temperature was
Let's see.
like -14.
Okay, let's see. You might be right. It might be something well below zero then. See. So we're in this purple color, solidly in it. That's about -10. So you've got to add 9-ish. Yeah, we'll be about 32, 33 degrees with sun out, if the sun comes out. So it'll be colder than 40 at game time. And who are we playing tomorrow? Who's the hapless opponent tomorrow?
Illinois.
Oh, Will.
Plus,
Doubly
but
hapless.
the kicker of the whole thing is it'll be super windy.
Yeah, that's right. It will be windy and cold. It's not a day you want to be at that game. You'd much prefer to be at game 7. Much prefer to be at game 7 under a domed stadium where the temperature inside is 68 degrees and it's 13-1 after the 4th inning. Which is what I'll be doing. Very, very cold. Now let's see how quickly it dissipates. So this is midday Saturday. So it's going to be a cold, cold Saturday. And I think snowy in the morning. So let's go to 36. Let's try 36 hours. Then we just do 850 because we know the wave's moving away. So we're still about as cold as we were at noontime by tomorrow night. So the whole day tomorrow is going to be cold. It's going to be a cold walk to the game, but a warm, buoyant walk home. And then at the surface, let's just get an idea how windy it'll still be. Yeah, the winds will begin to die down late in the day, but they won't have died down completely. And the coldest there is going to be over the northern counties of Indiana and Ohio. So this is lake effect snow for sure. Some of it in South Bend, places like that, Fort Wayne, probably also in the northern tier of cities of Cleveland for sure, is related still to our wave. As you can see, it's kind of patchy, but then Cleveland all the way to Akron at risk for seeing snow tomorrow. So pretty interesting. And then we'll go 42 hours, Pete, see how that looks at 850 first. And here's where we start to see a considerable retreat of the cold air. So now we're in the 3rd or 4th shade of blue. It's maybe about -6. So that's like 6 degrees warmer suddenly. And then the wind, I think, will have died down as well by Saturday midnight, when Milwaukee will be on fire pretty much. So can we go to the surface?
In a good way or a bad way?
Well, that's the question. We hope to rise above the citizenry of Detroit. When they win championships, they do damage. I hope we just walk home happy. So, big anticyclone sitting sort of over Kansas City, widespread weak pressure gradient force. So it will be windy, not windy, I'm sorry, it'll be windy to our east, but not over us. And we'll probably be really cold one more time, but Saturday morning may be colder than Sunday morning. But not by much, because this will have radiation effects that'll help. It was Saturday, it'll just be cold convection. And then I think we'll go maybe 12 hours ahead, just so we're not in such a slow pace. And by then you can see there's a little bit of a troughlets that comes along in the lee of the Rockies. This has got, again, the lee side characteristic of the warmest air and the axis of the trough. And then southerly and westerly flow across that gradient of temperature that sets up, warms us up considerably. So we're back to and above zero by the time you get to midday Sunday. So it'll be really cold tomorrow in the midday, wintry type day all the way through. And you might notice if you're out late that it's actually not as bad at night as it was in the middle of the day. And then by Sunday, it looks like we'll come back to something closer to climatology. So that's the story for the short-term forecast.
What's it look like at 500 millibars at that time? Is that ridge holding like that on the west coast?
Probably it is, although I don't know for sure. Yeah, it is. It's just not as intense. And it's another one of these things with the weird wind. Let's get a time adjacent to this week, maybe 57 hours. Yeah, that looks better. It looks like it's better
Still
behaved.
there.
So it's still there, and it's and now it's sort of an omega block, right? That ridge over the.
It's like it's still Rex block. 'Cause you got-
Oh yeah, it's Rex is when it's like that. The other way is that's right. That's what it's named. So here's our ridge, and that keeps us in a westerly flow with a northerly component, which makes it hard to dig out from slightly abnormally cold temperatures. If it becomes zonal, we warm right back up. So, but it may not with this ridge sitting there. And here's another nice example, actually. We can go to the surface map just as the last thing. Here's a couple of strong positive and negative vorticity. This negative vorticity, I'll bet you 100 to 1, there's a band of heavy precipitation in the forecast right there. Let's see. Yep. So that's a nice squall line sort of feature that's tied to, or at least probably helping to promote the negative vorticity that you observe at 500 millibars. Look at that. 1046 in the North Atlantic. That's intense. So that's what I have for you.
Pete, can you put up the, before we go, could you put up that inertial frequency plot which shows the plumes?
You got to explain it, Greg. I don't know what to say about that.
Just 340 without jet. 360. So, yeah. This just gives you a feeling for what's, no, not that one, the 340, without the inertial frequency. 348, I'm sorry, without jets. No, do without the jets, as you can see that. Okay. Yeah, this is, if you see these plumes coming up in the tropics, if you look closely here, you can see the hurricanes.
That one you can see easily,
Yeah, you can see the hurricanes and how they're at the source of these plumes, even one out here. Look at these plumes coming up. As these plumes come up, these are defining the subtropical jet. You look at what's going on in the polar latitudes, you can see one plume after another. Look at this one at the end from this hurricane reinforcing this plume coming up. So what's happening with these ridges is these are pulses coming out of the tropics that are defining this extratropical weather right now. It's just one pulse after another pulse. It's fascinating to watch this. At the edges of the pulses, you see these, what we call spokification, where it kind of gets all these little things, ripples. That's because these plumes in the upper levels are driving the inertial stability so low that they can no longer support quasi-geostrophic flow, and everything breaks into gravity waves. So these are gravity waves forming at the edges of these plumes, and usually associated with that, there are thunderstorms and so on too. But what's interesting is you can see these pulses coming out of here are really defining our weather right now, more than anything moving around the poles. The poles are just kind of reacting to it.
I don't know if I agree with that. I mean, we saw really strong cyclones up in the Bering Sea south of the Aleutians,
There's one here.
totally reinforcing that high amplitude ridge.
So, these plumes actually work with the cyclones too, because when these plumes come up, they lower the inertial stability on the eastern side of the cyclone, and then the rising motion that makes a low pressure at the surface becomes very strong. When these plumes come up into the warm sector of the cyclone, it creates a bomb. It turns the cyclone into a rapidly deepening
Okay,
entity.
that
It just
I can get on
overturns
board with, but there is some mid-latitude dynamics that
There's mid-latitude
is
dynamics,
perturbing it in the first place.
but the mid-latitudes, I think, are rendered receiving pulses from the tropics that are defining what's going on right now. And one of the reasons that's happening now, and it won't happen later in the winter, is that we don't have a polar night jet. And once the polar night jet forms, which is more in November, then we get a different kind of weather governing things. But there's no polar night jet right now. So we're really just feeling tropical plumes coming out,
So
one after the other.
that's kind of an interesting idea to chew on, is how much of a window is there between the die down of the tropics and the establishment of a robust polar night jet? And then how variable is that from one year to the next? That might be a really
I think it's
important
actually
quantity.
Quite variable. It was interesting that you saw the polar night jet down here in the global plot of the jets. There's still a polar night jet down in the southern hemisphere. It hasn't gone away yet. But once the polar night jet forms, it tends to create a wave number 2 or 3 with vorticity in it, and then the subtropical jets and the polar jets will go up and connect with it. And when they do that, they drive the cold outbreaks. So the big Arctic outbreaks are really triggered by the interaction of these plumes with the polar night jet.
And those plumes, but the plumes can be driven by extratropical developments
the
once
plumes at that time of year, by the time
once the
you-
tropical systems
Yeah,
are done,
absolutely.
right? Yeah, that's really interesting. That's an interesting way to think of it. And there might be some way to actually get a reasonable measure of, in a given season, when is that window where they're not established and can't interact? And what's the weather? Is that a period of the worst predictability of the whole
Well,
year?
we did this study, and the one thing we found was that window is very unpredictable in the northern hemisphere. The southern hemisphere is very predictable, very regular. Northern hemisphere, sometimes you go a long time before you
Yeah.
break into that flow. But once you break into it, that's really the transition into winter.
Yeah, that's interesting.
Because the polar night jet seems to be what actually triggers, even though it's way up in the stratosphere. When these tropical plumes come into it, they deepen it down to the surface and create an extra tropical jet that lifts the cold air off the ground in the poles and creates these polar outbreaks. So the interaction of these plumes with a polar night jet is what triggers the polar outbreaks. And then you get all kinds of extratropical weather once that starts in.
Yeah, very interesting. Well, any other comments or questions?
You have a sounding from 7 o'clock in the morning tomorrow?
I have it in my head. I can't really project it. No, well, we can probably find one. We have one, right, Pete?
You're getting a snow shower?
I think so. Don't you think so, Chris? Doesn't that look like it's gonna happen?
Yeah, that's great.
What's the temperature of Mendota right now?
What, the temperature?
Yeah.
I don't think I know that. Yeah, there's a buoy that has, I think it has 5-minute data or something like that. And it's down several different layers, but I don't know what that is. That's a good question.
This is for today. You want tomorrow morning?
Yeah.
Yeah,
that's
Yeah,
down there.
sounding. I don't know, I think my buck, yeah.
They got it on that.
And let's do Green Bay as opposed to Davenport, or, because Davenport's out of the influence of that PBA.
Oh, yeah.
Yeah, 0 meter, so 40 salt.
54. This is Utah. So it's dry in the lowest layers, it's saturated about 800 millibars, or close to saturated 800 millibars. And then if you can get it close to saturation in the boundary layer, you can get something to happen that might be slightly convective. This will be forced to set though too, which is good. So this air here will certainly condense because it's going to be forced to rise even in the face of negative area. So we won't be convective, but it'll be forced. And that's okay with me. I don't care how we get it.
What about for, wait, is this Jersey or what about calls?
This is 12Z tomorrow morning,
Is it?
roughly Madison.
No, it's like 36.
Oh, wait, no, I'm sorry, that's 20, that's tonight.
Oh,
There you go.
My bad. That's the 12-hour forecast, it should be.
oh, even better. That's nice. Let's get it. No resistance at all to turning that high relative humidity into precipitation. And zero line. There's the zero line.
Where's -10?
Sorry?
Where's -10?
The -10's right here. So that's -20, so it's right in between.
I can see some dendrites.
Yeah. I mean, it would be really quite nice to see some obvious snowflakes and not just graupel.
Yeah.
So this will be great. Tomorrow morning, 9 o'clock.
Book it.
Yeah, book it. I think so. I think we can.
Like 3 hours.
So anything else? All right, thanks, everybody, and I hope you have a great rest of the day and the weekend. We're gonna be here all weekend, so. Thanks to Pete, thanks to Greg. And Brian, too, and Chris.